Assalamu alaikum dear students, and our today's topic is the Ohm's law, one of the most important laws of electrodynamics, or you can say current electricity. So the Ohm law states that the current inside a conductor is directly proportional to the applied voltage across the conductor, provided that the temperature and the physical state of the conductor does not change. So basically, what does it say mathematically? The current inside a conductor. The current inside a conductor is directly proportional to the applied voltage across the conductor. The current is directly proportional to the voltage applied across the conductor, provided that the condition is that the temperature and physical state of the conductor should not change. It means that we should not change the conductor's temperature, and we should not just change the physical state of the conductor. We should not increase the length of the conductor, meanwhile we should not actually increase the area of the conductor meanwhile. Okay, so the current inside the conductor is increased or decreased as directly proportionally to the applied voltage. So the higher the voltage, the higher would be the current. The lower voltage, the lower would be the current. So यहाँ पर हम क्या करेंगे, प्रोपोर्शनैलिटी के साइन को हटाएंगे एंड वी विल इंट्रोड्यूस ए कांस्टेंट एंड इक्वालिटी साइन. So it will become I equals to kV, where k is the constant and k की वैल्यू होती है 1 by r. R is also a constant over here. Okay, 1 by r k की वैल्यू है. अब हम क्या करेंगे, k की जगह 1 by r पुट करेंगे. It would become 1 by r into v. 1 into v becomes v by r. This is the equation for Ohm's law, where r is called resistance. And resistance हम अपने next topic में पढ़ेंगे, exactly thoroughly पढ़ेंगे इसे. Resistance that does not depend upon v or I. You can just see it over here. Resistance को अगर हम इसके दूसरी साइड पर ले जाएं, करंट को इस साइड पर ले आएं, then resistance would be equal to v by I. And V by I is the ratio of voltage and current, which actually are directly proportional to one another and will not change the ratio of V and R. Okay. So resistance does not depend upon V or I, rather it depends upon the nature of the conductor. Okay, so we have to just clearly see that which conductor are we going to use, and its dimension, what would be the length of the conductor, what would be the area of cross section of the conductor, and its temperature. At what temperature are we going to supply that current? Okay, so this is the Ohm's law, and it just says that as we change the voltage, the current will change, or we can say that the current produced is equal to the applied voltage divided by some amount of resistance in that circuit or the material. So there are basically some kind of limitations to the Ohm's law. Ohm's law is not actually valid everywhere. So the materials which obey Ohm's law are called ohmic materials, and the materials which just do not obey Ohm's law are called non-ohmic materials. Okay, so Ohm's law is only valid if R is constant. Okay, so what does it mean that R is constant? It means that I equals to VR. We are going to use this equation I equals to VR, which gives us R को हम दूसरी साइड पर ले जाएंगे, R को और I को दूसरी साइड पर V के साथ डिवाइड कर देंगे. It would become R equals to V by I. V and I are here directly proportional. So अगर V को increase करते हैं, I भी increase होगा, so that the ratio of these two things will remain constant. Okay, it doesn't mean कि V constant रहना चाहिए या I constant रहना चाहिए. It just means that इनका ratio same होना चाहिए. For example, अगर start में हमारे पास 6 volt हमारे पास voltage थी and I हमारे पास 3 volt था, so the ratio would be 2. अगर हमारे पास उसके बाद जो हमने रीडिंग ली उसमें 12 वोल्ट हमारे पास वोल्टेज आ गई एंड 6 वोल्ट करंट आ गया, then still the ratio would remain 2. Okay, because 6 divided by 3 would become 2, and 12 divided by 6 would also become 2. So the ratio of V and I will remain constant over here. So for ohmic materials, the ratio of V and I remains constant, and that ratio is called the resistance of that material, and it actually is this resistance actually depends upon the nature of the material and not upon the V and I. So यहाँ पर मैंने 3 ग्राफ्स ड्रॉ किए हैं just to show that which kind of materials obey Ohm's law and what does it mean? What does it mean by this equation, of course. So the first graph is for ohmic conductors. You can see over here we have suppose 1 volt, and we have here 1 ampere, and we have 2 volt, and here we have 2 ampere. So for every increase in voltage, the current will be increased likewise. Okay, जितना हम लोग वोल्टेज को इंक्रीज करेंगे बिल्कुल उतना ही करंट इंक्रीज होगा. जितना हम वोल्टेज को यहाँ पर इंक्रीज करें बिल्कुल उसी तरह से करंट इंक्रीज हो रहा है. Okay, so it just state that the graph between V and I would just remain a straight line. It will not follow a curved path. The materials for which the graph between V and I remains a straight line, this line is called the resistance. These are called the ohmic conductors or ohmic materials. But on the other hand, we have some other kind of graphs as well, and these graphs are for non-ohmic materials. Both of these graphs are for non-ohmic materials. It just says that यहाँ पर आप देख सकते हैं हमने वोल्टेज को काफ़ी इंक्रीज किया, बट द इंक्रीज इज करंट इज नॉट सो मच. ओके, वोल्टेज यहाँ पर काफ़ी ज़्यादा इंक्रीज हो चुकी है, एंड there is just a little increase in current. So these kind of graphs are just gives us a kind of curve in the graph. Okay, they don't give us a straight line, they give us curve, either exponential or negative exponential. These are called exponential curves. Okay, this is a positive exponential curve and this is a negative exponential curve. So we have to know that in both of the cases, यहाँ पर आप देख सकते हैं हमने वोल्टेज को बहुत थोड़ा सा इंक्रीज़ किया है, करंट कितना ज़्यादा इंक्रीज़ हो गया है. ओके, सो यहाँ से हमें पता चलता है दैट देयर इज़ नो लीनियर रिलेशनशिप बिटवीन वोल्टेज एंड करंट, बट हियर इन ohmic materials there exists a linear relationship between V and I. Therefore such materials which give out this kind of graph are called ohmic materials, and they obey Ohm's law, and hence their resistance value for any kind of V and I ratio is constant. Okay, so this was all in today's lecture. Thank you so much everyone.